Module C gets even more interesting. So, based on our conversations on Module A and B, what do you understand by machine learning? And you know what? This is a safe environment. There is no right or wrong answer. We are all getting to the destination together. So tell me. Very good. Very good. Machine learning, I will take that. Machine learning is how a machine learns. So in this particular section, we are going to quickly define what AI or artificial intelligence is, what machine learning is, what is deep learning, and then we're going to dive a little bit deeper. Meaning of machine learning, the ways in which a machine learns, supervised, unsupervised, semi-supervised learning, what do they even mean? Then we're going to quickly define regression and classification and take a look into deep learning. Our goal in this section, ladies and gentlemen, is to really understand these concepts in a technical but very simple manner. And then we're going to, in the later sections, dive into the technical and math details of these topics. So the foundation is built in this section. Artificial intelligence. So let's talk about that first. What do you mean by artificial intelligence? Anyone? Good. How about someone else? Very good. Exactly. You are all right. Artificial intelligence is artificial because it is not human intelligence. It is not real intelligence. You know how the dictionary defines it? The dictionary defines artificial intelligence, or AI, as the capability of a machine to imitate human behavior. Now, you're going to hear these terminologies used in marketing, all around in your domain, in your work, in your interviews. So a quick way to define artificial intelligence is the capability of a machine to imitate human behavior, and machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. Any questions? And of course, like always, please feel free to interrupt me at any time you have questions. Very good. So how about some of the applications of artificial intelligence? How about, yeah, go for it. Very good. Siri is one. Alexa is one. That's good. Gmail is one. You know what? It's just not Gmail. Google's every app, whether it's Google Translate or Gmail, for instance, or any other application of Gmail, or even LinkedIn. How about LinkedIn? How about Facebook? Good. Snapchat is another one. So today there is not, you tell me one app and I will tell you that we are immersed in artificial intelligence. Self-driving cars, product analytics like on Facebook, A/B testing, image recognition, speech recognition, language translation, sentiment analysis, recommendation systems. You guys, anyone who has not used Amazon or Netflix, just like we see in the movies, exactly, very good. Image reconstruction also, guess what? That screening software platform, without even going into the doctor, we can actually have these apps where the doctor looks at us and with our facial expressions, they can actually diagnose what's going on with us. Isn't that cool? Yep. So guess what? Welcome. You are in the right class and you are learning the top technologies. So let's do a quick quiz. How do Google, Amazon, and LinkedIn build API in their ecosystems? A, Google, Amazon, LinkedIn, they don't use AI. B, Google and LinkedIn, through their offerings, Amazon does not use AI. C, Google and Amazon use AI. LinkedIn is in talks to use AI. And D, Amazon uses AI. Google uses Vision API, Google Translation, LinkedIn, the entire job application process. Take a guess. There is no wrong answer. Okay? And why? Why is it D? Very good. I'm so proud of you. You guys are doing great. And you know what? You're absolutely right. LinkedIn, Google, and Amazon, and just like we chatted, they all use artificial intelligence. Great. Ready to move on? All right. Machine learning. Just as all of you mentioned, machine learning is basically how does a machine learn? So machine learning, let's quickly define it, take the basic definition of machine learning. It provides the ability to automatically learn and improve from experience without being explicitly programmed. This is key, ladies and gentlemen. Without being explicitly programmed. You know what? Let's go back. let's ask ourselves this question. What does a computer program mean to us? Because machine learning is different than computer programming. Okay, very good. So Jack says the computer program is basically summing numbers. You know what, we'll take that example. So just as in computer program, we explicitly tell the computer what to do. We give it, say, 10 numbers and say, hey, add these 10 numbers and give us the sum. In this case, we have told the computer what to do. In machine learning, by contrast, we do not tell it what to do. We give it a bunch of data and we expect the machine to learn. Are there patterns? Or say if we give a bunch of features to a house price, can the machine tell us what the sale price of the house is going to be? So that is machine learning. So quickly, how does the machine learning? Or how does the machine learn? There are 3 ways. Supervised learning, unsupervised learning, and semi-supervised learning. So ladies and gentlemen, you know what? You are in this class to learn all of this, but we are going to break this down real simple. What do we understand by the term supervised? Whatever you understand by supervised, don't even worry about anything else. What do you understand by supervised? Gaurav, pretty good. Supervised meaning somebody's supervising us, meaning somebody is there to tell us what to do. Unsupervised? Alicia, very good. Unsupervised meaning someone else? Jacqueline, very good. So unsupervised learning, anyone else? Very good. Unsupervised is just the opposite, right? Meaning somebody is not there to supervise us. So it's not there. So very good. That's exactly what we're going to take into machine learning. And semi-supervised meaning in between. Some of it is supervised, some of it is unsupervised. Say we are playing, our mom or dad or guardian or caretaker is there part of the time they're not. So semi-supervised learning. Same for the machine. So let's take an example. Supervised learning is where, for example, let's look at this example. We take some known data, in this case, pictures of these red figures, and we feed a bunch of them. And the key is we feed a bunch of them, a lot of them, into the machine. And we tell it, whenever you see these red shapes, these are actually apples. So what we're doing is we're telling the machine that giving the machine some input, which are, say, in mathematical terms, x. And we're also telling it what the y, or the response variable to these x's are. So these are these red shapes and what they mean, x and y. So we are telling the machine, teaching the machine, that when you see these red shapes looking like this, they're called apples. Now I'm going to introduce a new term. It's called training data. So we are training the machine. Whenever it sees the shape of these apples or sees the shape of these red figures, it knows these are apples. So what happens is, then when we feed a machine another red shape that it has never seen before, this is called test data. That's right, training and test. I've just introduced 2 concepts. In the later sections, we're going to dive deeper more, but just get just the basic understanding down. So what we do is, when we feed this new data into the machine, this new red shape, based on the training data that it has learned, it's correctly able to predict that it's an apple. This is an example of supervised learning. Everybody still following? Great. Another example. So what we're doing here is we're giving the x and the y both to the machine and giving it enough so the machine learns the pattern. And then we give it again another x that it has not seen before, but of the similar type. The goal is to correctly predict that, oh, this was an apple. So give me another example. Let's take another example. How about predicting house prices? Anybody here who is not familiar with this? It doesn't matter if you're buying a house or renting an apartment or even a house. Great. So you know what? Give me some factors that you think determines the house price. Location is one. Very good. How about someone else? Yes. Number of bedrooms is one. How about someone? Yes, very good. Number of bathrooms is one. Number of car garage space is one. Year it was built is one. Great. So all of this, so what happens is we take historical data. We take a bunch of these things that you just all mentioned. These are X's or inputs or known data. We take all of this and we take the corresponding list of houses. So we take a bunch of training data. We're going to start using that term. Training data of a bunch of houses for which we have these features or X's, like location, year built, and their corresponding Y's with the sale price of the houses. We feed these into the machine. And what the machine does when we give it a new set of X's, based on all of this training data, when we give it a new set of X's, our goal is that the machine will be able to predict the sale price of a house in the future without seeing the data on this new data. So you know what? Opendoor, anyone heard of Opendoor? Zillow, Redfin? Yes, that's right. All these startups have, behind the scenes, they're running this kind of supervised machine learning. Any questions? Yes. Yes, absolutely right. See, car, based on the weight of the car, what's the mileage of the car? See, again, we have taken an X and a Y and we feed that information. And that's another example, great example of supervised learning. Very good. All right. Unsupervised learning, by the same token, say we are not feeding in, we are just feeding in a bunch of images, a bunch of patterns. In this case, the red figures, the yellow, and the green figures, which are all different shapes and they look different. We are feeding that into the machine, a lot of training data. Remember, training data. So the X's we're feeding in. We are not feeding in the Y's into the machine. So we're feeding in a bunch of data where the machine is learning that, oh, these are all different shapes. What we expect is if we had given the names, that would have been Y's, but we are not giving the Y's to the machine. So we are feeding the X's or the features into the machine. And we're expecting the machine to notice the difference or tell us if there's a pattern in this input data it is seeing. And that's why it is called unsupervised learning. So we do not feed in the Y. The machine itself, if it sees enough of it, when we give it a new unseen pattern, say we feed in a new unseen, say a red or a green or a yellow figure, the machine correctly classifies that into say, hey, this is the pattern I'm seeing. This is the red, these are yellow, these are green. And this is an example of unsupervised learning. Remember the company I work with? I was telling you Litterati, where we collect litter. People pick up litter from the different parts of the world through our app. And so what happens is, see this figure? This is the geospatial distribution of the numbers that we see in those circles are the numbers of litter that have been picked up in each of these places of this world. Now, as we dive detail, we can see the distribution of litter. But what do these things mean? We have given the machine the input that, hey, we have picked up litter at these places, but we don't know what that means. So we cannot feed the machine Y. Right? So we just feed the X and we want the machine to tell us these patterns. And there are different ways, and in the future sections we're going to go into some technical terminologies like, very good, that's right. K-means clustering, DB-scan, EM clustering. Very good. You guys have done some of the homework and the resources I had given to you. I'm so glad. And those of you who haven't, that's fine. We're going to all get to the destination together. But exactly. So long story short, unsupervised learning, we feed the X's or the features and we expect the machine to tell us what patterns it is seeing. Supervised learning, meaning we are giving the X's and the Y's, and when it sees a new X that it hasn't seen before, it should, based on that data, it should be able to predict Y correctly. Great. And you know what? I'm going to keep this simple. Semi-supervised learning is in between supervised and unsupervised, meaning some of the desired are there, some of the X's and Y's for some of the data is given, some of them just X's are given, and we expect the machine to learn the pattern. We're going to dive into detail later, but just get the concepts down. Once we have the foundation in place, ladies and gentlemen, everything else, the technical details and math become easier to understand. Great. So the takeaway from what we just looked at is that, you know what, based on what business challenge we have, we decide whether the algorithm or the machine learning model we as data scientists are going to build is going to be an example of unsupervised, supervised, or semi-supervised learning. Questions? Great, yes. Yes, we're going to go into the math and the technical detail in the next section. Any more questions? Great, okay. So now another thing we're going to run across is regression and classification. You know what the deal is? Regression meaning, once we build a machine learning model, what are we doing with the result? So I'm going to make this very simple with an example. See the house prices example we just took a look at? We took a bunch of features, so input X's, and we're calculating a value of the house price. So Y, a value. Whenever through a machine learning model we're predicting a value, it's an example of regression. Now, on the other hand, for example, we are teaching a machine that, hey, if you see images of cats and dogs, you should be able to label the cats as cats and dogs correctly. So what we're doing is we are not having the machine calculate a value, but the machine is taking a bunch of inputs, X's, and assigning labels correctly or classes correctly. So differentiating a bunch of images into cats and dogs. These are examples of classification. And in machine learning model, what we do with the results are either classification or regression. Either calculate a value, which is very good, regression, or we assign labels or classes to a set of input data, and that is classification. Great, that's all you need to know. Isn't that simple? Great, you guys are almost there. And then deep learning. We're going to go into details in the future sections. But let's break this down. You know what deep learning is? Let's take this concept. Have you ever noticed that a kid, when a baby is born, they're hardly able to differentiate between images, right? But around the age of 1 or 2, what they start doing is they're able to differentiate between cat and dog, or Coca-Cola can, or Pepsi can. How? What happens is we feed the data and we're using the term, the kid or the baby tends to see a lot of these images, say cats, dogs, Pepsi can, Coca-Cola can. And then what happens is they're able to, when they see a new unseen piece of Coca-Cola can, they're able to classify it correctly. And that's exactly what deep learning is. What we do is a machine. So you know what? I'm going to ask you, ladies and gentlemen, a question. Do you know how many neurons are there in a human brain? Yes, very good. That's right. 86 billion neurons are there in a human brain. So you know what happens is when the baby is seeing, say, cat and dog, and it keeps on seeing cats and dogs under a blanket, in the field, pictures of cats and dogs, people around them are correctly classifying cats and dogs, the neurons, each part of the human brain, starts to differentiate between a cat or a dog, or between two kinds of dogs. In this case, say, a brown Doberman and a black Doberman. What was that, Martha? You're right, these are my dogs, yes. Yeah, but thank you. Yeah, I like them too. So moving on. So what happens here is, each part of the human neuron brain is actually able to pick up on what the ear, the face, the body, the legs of cat and dogs look like. And each part of the neuron does. And so when it sees a new image of an unseen image of a cat or a dog, it's able to use all that information the neurons have learned in the human brain and correctly classify cat or dog. You know what? We want to accomplish the same thing with machines. And with machines, that when we use it in that method, we call it deep neural networks or deep learning. So in machines also, we have something called a neural network. So we built out a bunch of layers. And I'm just going to keep it simple. We're going to dive into detail in the sections. But all I want you to understand right now is that there are layers. There's an input layer, output layer, and hidden layers, at least two, inside the input and the output layer. So the input layer could be the images of the cats, and output layer would be the correct cats and dogs input layer. Output layer would be the correct classification of whether it's a cat or dog. And in the hidden layers, just as in our human brain, the different neurons, they work together to correctly do some calculation to decide whether this was a cat or a dog. Similarly, in machines, we build out a similar network analogous to human brain, where different layers work together and kind of correctly signify or correctly classify whether it's a cat or a dog. And you know what? We're going to dive into the math later on, but it is so fun, isn't it? And what happens is the machine gives us a probability probability and mathematical concepts also we'll get to learn, and some of us have already learned it. Very good. Probability is that, for example, in this case, the deep learning model, it is telling us with a 0.997 probability that it's a dog. 0.97% probability, or 0.979 with 0.979 or 97.9% probability that that's a person, or 99.3% that it's a horse. Everybody with me? Great. You know what? This was just an intro slide. And so the key takeaways from this that we wanted to go over, just the basic concepts, to understand artificial, machine learning, and deep learning, what they are. Artificial intelligence is a superset, machine learning is a subset, and deep learning is a subset of machine learning. And then we have a bunch of areas of application. Anywhere, anything you use, any app you use, then you're probably using machine learning in some way or another. So you are in the right field. And then machine learning definition we learned. What are the different ways machine learns? Supervised learning, unsupervised learning, semi-supervised learning. And deep learning is analogous to how humans learn. Example, object and facial recognition. Great. Great. Questions?